Yesterday, we briefly started the 8-5 lesson, and it's all about solving quadratics by factoring. So we've learned how to do it by graphing. That is when you look at the x-axis and say like what x values it crosses at. Well, to solve it by factoring, you follow these steps. You set the quadratic equations equal to 0. You factor one side of the quadratic equation, set each factor equal to 0, and then solve each factor for x. That's like the basics of it. I guess the hard part is remembering what factoring method to use and when. So if you have that flow chart from when we did the factoring unit, right, it says GCF at the top and then 2, 3, and 4 terms.
Attention seniors, just a quick reminder, the U of A Step program is going on right now in the lecture hall. So if you have been admitted to U of A, it is time.
All right, but as I was saying, just if you have that flow chart from when we did the factoring, then that would probably be helpful to you. So we're going to do a lot of examples today. And the reason why we have to do so many, like normally I try to do, I don't know, no more than 4 or 5, because I know it's hard for you guys to pay attention. But the reason why we have to do so many is because it's been at least a few weeks since we've done factoring. So we have to review those methods. If you missed the 2 examples we did yesterday and want to check them out, it's linked in yesterday's lesson. I'm recording now. I'll link today's lesson in here. And we should get through the whole lesson. The practice will be evens or odds. So far, on average, my classes have had like 10 minutes today to work on it. On Monday, I don't think I'll give you more than like 15 extra minutes, and then we're moving on after that. So if you think it'll take you longer than that, then do work on it over the weekend, because I'll check it Monday. Just evens or odds too. The exit ticket for it probably won't be until Wednesday, because we're having to kind of split it into a day 1 and day 2 lesson. So like day 1 is when the leading coefficients are 1. So not like a bunch of crazy factoring that we have to do. Day 2 will be when the leading coefficient is not 1. So like factoring with slide and divide and stuff. So exit ticket will probably be Wednesday. The rest just kind of depends on how fast we go. We are trying to work ahead, so that way we have enough time to do fun review days and things like that. So stay tuned. The Aspire test is on April 12th. Everything is in preparation for that. All right, so here's where we left off on the notes. We did one example together here, and then a U try down here. So now let's look at number 7 together. And then you'll try number 8. So go through the steps that are at the very top of your page. So step 1, make sure the quadratic equation is set equal to 0. So is it equal to 0 right now? Great. Then first step is already done. You'll notice that it's already done in 1 through 16 on your notes. All right, we'll get to some examples where we actually have to move stuff around. All right, but so far it is equal to 0. So just move on to step 2, which is to factor the other side. When it's a trinomial, how do we factor it? With the diamond method. So A times C on the top, B on the bottom. What number is in the A position? What number is in the C position? What's 1 times 25? Good. And what number is in the B position? 10. So then I need 2 numbers that multiply to 25 and add to 10. Both positive. Yes. So then so far I have x plus 5 in parentheses times x plus 5. Still equal to 0. We'll add you to the line. I think you'll be after Danelle. So then after step 2, what do? What does step 3 say? set each factor equal to 0 and solve for x. So factors are things that you multiply together. So like parentheses times this other parentheses. So x plus 5 equals 0 and x plus 5 equals 0. How do you get the x by itself? We're going to subtract 5. That's how you make it equal 0. And whatever you do on one side, do to the other side of the equal sign. So 5 minus 5 is 0. The x is by itself now. What's 0 minus 5? Negative 5. And then it happens to be the same exact equation over here. So the other x is also negative 5. Now, when I write my answer with the curly braces, do we ever like repeat numbers? No. So I don't know if you remember when we did domain and range toward the beginning of the year and we used the curly braces. But if there's repeating numbers, you don't write them more than once. So this is an example of when the quadratic has just one solution. So it touches the x-axis in only one spot. That makes sense? Any questions? All right, then you try number 8. I'll project that answer in about 90 seconds. First thing you should have done is made sure that it's set equal to 0, and it already is. Second thing you should have done is factor the other side. And when it's a trinomial in that format, you use the diamond method. So 16 should have been at the top, negative 8 at the bottom. What are two numbers that multiply to 16 but add to negative 8? Negative 4 and good. So a lot of students just do that and then they stop. So if you said that your answer is negative 4, that would be incorrect. So don't skip steps. Continue on with step 3, which is to set each factor equal to 0 and solve for x. Because how do you get rid of a minus 4? You add 4, and you do that to both sides of the equal sign. 0 plus 4 is a positive 4, not a negative 4. All right. Usually when they're nice like this, like no slide and divide, it's usually just those numbers with opposite signs. All right, but still go through the steps. And since it's the same equation, you should only have one number in your curly braces. Questions? All right, so then let's switch it up a little bit on the back side. So now we're gonna look at other methods of factoring. So just to like refresh your memory, let's go through that flow chart. What do we always tell you to look for first when you're factoring? If you said GCF, then you're correct. Okay, if you said GCF, then good job. I knew there wasn't one in the first examples, but really you should always check for a GCF first. If there is one, then factor it out. So like in number 9, is there a GCF on this side? Well, not between 1 and 8, but do they both have x's? Yeah. So then factor out an x, and always factor out the one with the smaller exponent. So like x will be our GCF. When you're factoring out your GCF, the GCF goes outside parentheses, inside is what you get from dividing inside of GCF. What's x squared divided by x? What's negative 8x divided by x? Negative 8 is correct. And then sometimes after you factor your GCF, then you're done. Like in this one. I mean, we still have to do the solving, but let's finish writing the flow chart now. All right, so let's say you factor out a GCF and you still have to factor further. What do you look at next? The the number of terms. So like if there's 2 terms, 3 terms, 4 terms, that tells you what method you use for factoring. So if there's 2 terms, what method did we have to use, or see if it was? $13 and $14 would be an example of it. Difference of squares. Guys, some of you have your flowcharts out here, it's not saying anything. All right, but yeah, if it's 2 terms, see if it's a difference of squares and then factor it that way. If it's 3 terms, then it has to be in this format if you're gonna factor it. And how do we factor stuff in that format? The diamond method. So A times C on top, B on the bottom. And we're not gonna do it today, but if A is a different number other than 1, what do you have to do after the diamond method? Slide and divide. All right, I'm just kind of rough sketching the flow chart for you. So that's when A is not 1. So when A does not equal 1, you have to do the slide and divide step. All right, if it's 4 terms, I haven't seen that in this unit, but just for fun, what's the only way we know how to factor 4 terms? Good. All right, so here's like your flow chart reminder. These are basically the steps you go through when you're factoring. All right. In number 9, we can only factor by GCF. So questions about that so far? All right, so after you factor, you set each factor equal to 0 and solve for x. In this case, my 2 factors are the x and the parentheses. Because it's normally x times the parentheses. So set each one equal to 0. So I have x equal to 0 and x minus 8 equal to 0. And solve for x, which basically means get the x by itself. Is the x already by itself on the left side? So that means one of my solutions is 0. On the right side is x by itself. How can I get x by itself? Add 8 on each side, and x equals 8. So for number 9, our answers were 0 and 8. All right, so it won't always be the diamond method that you use. Just depends on the situation. Let's do 10 together, and then I'll give you one to try. Just because I had to stop and explain a lot in number 9, so let's do 10 together. First thing, you make sure it's equal to 0, and it is. Then we factor the other side, which uses these steps for factoring. Look for a GCF first. Is there one? What is it? 3x is correct. That number will go outside parentheses. Inside parentheses is what you get from dividing it by the GCF. So like, what's 3x squared divided by 3x? 1x, or just x. Then 15x divided by 3x.
3.
Not 3.
5.
5. Right, the x's cancel, 15 divided by 3 is 5. If you're confused on how we got 3x as the GCF, always look at the smaller of the 2 numbers. If it divides evenly into both, like 3 and 15, divides evenly by 3, then that's part of your GCF. To factor out a variable, it needs to be present in each term. So I can factor in x from each term. All right, and this is still equal to 0. All right, after you factor, what do? read step 3 on the front of your notes. Set each factor equal to 0 and solve for x. Now my factors are the 3x and the x plus 5. So factors are things you multiply together, like the 3x and the parentheses. So set each one equal to 0 and solve for x in each situation. What's the opposite of multiplying by 3? So we'll do that for this equation. The 3's cancel. What's 0 divided by 3? 0 is correct. So that's one of my answers in the curly braces. Put it over here. All right, the other is what we get from solving for x over here. So how do I get x by itself? Good, and then x equals -5. So that will go in the curly braces as well. I know on the answer key for your practice, they always put like the smaller number first. It really doesn't matter at the end of the day. As long as they're both there in the curly braces, it's fine. All right, go ahead and try number 12. I'll project that one in about 90 seconds. So number 12 is projected. If you were doubting your answer because there was a fraction in there, it's okay for x to be a fraction. All right, so you should have had 0 and 3/4 if you solved it correctly. All right, so number 12, you should have made sure that it was set equal to 0 first, which it is. Then you factor the other side. All right, the only way to factor the other side is by GCF. So what's the biggest number that goes into 8 and 6? 2. And then do they both have an x? Then you should have 1x as part of your GCF. All right, and then the rest you get from dividing each term by the GCF. So like 8 divided by 2 is 4. What's x squared divided by x? X squared divided by x is x. That's what we have here. All right. And then -6x divided by 2x. The x's cancel. What's -6 divided by 2? Good. And that's how they got what's in the parentheses here. All right. After factoring, set each factor equal to 0 and solve for x. So one of my factors is 2x. The other is the parentheses. So 2x equal to 0. What's opposite of multiplying by 2? And what's 0 divided by 2? 0. They don't show all their work, but that's how they got x equals 0. 0 divided by 2 is 0. On the other side, we haven't seen one like this yet, but I had faith in you that you knew how to solve it. Back when we did solving equations, I always told you to start with the number that's farther from the x. So you don't start with the 4 because it's pushed up against it. Start with the 3 because it's separated by the minus sign. What's opposite of subtracting 3? Adding 3. So I'll show you that off to the side here. Add 3 to both sides first. That'll cancel it on the left. On the left, I have 4x. On the right, what's 0 plus 3? 3. And then opposite of multiplying by 4 is dividing by 4. So then the 4's cancel on the left, and that's how we got 3/4 as part of our answer. If you made it 0.75, that's all right. But fractions are okay. So questions on 12? All right, then let's go back to the notes. Sorry if it's like kind of a little boring, but it's hard to like advance when you haven't seen it yet. Just in the trash. So now let's look at, we're going to skip 13 and 14 because 15 and 16 cover the same thing and they're a little bit more difficult. So we'll kill like 2 birds with 1 stone. So looking at 15, follow the steps on the front of your paper. Is it already set equal to 0? Yes, so then the first step's already done. Step 2 is to factor the other side. Is there a GCF between 4 and 81? No, there's not. If you're not sure, make a factor tree. All right, they have no common factors other than 1, and you never factor out a 1. Do they both have x's? So no GCF. Well then, let me look back to my flow chart from last unit. How many terms was there in number 15? 2 terms. Well, if it's a difference of squares, then I can factor it. So let's see. Is there a minus sign in between them? Yes. Are there perfect squares on each side of the minus sign? So then we can factor it using the difference of squares rule, which I'll write over here in case you forgot. So the difference of squares rule says that if I have a squared minus b squared, that's the same as doing a plus b. And what's the other parentheses? A minus b. That's your difference of squares rule. Makes you forgot. So then we'll apply that here because they are a difference of squares. What's the square root of 4x squared? Square root of 4 is 2. Square root of x squared is good. What's the square root of 81? So then one of the parentheses will have the square roots with a plus, and the other will have it with a minus. Bringing back memories, I hope.
Yeah.
All right. So then after you factor, what do? No. Step 3 on the front of your paper is to set each factor equal to 0 and solve for x. So then I have 2x plus 9 equal to 0 and 2x minus 9 equal to 0. Do I get rid of the 2 first or the 9 first? How do I get rid of it? Subtract it. Go ahead. And I'm kind of out of room, but opposite of multiplying by 2 would be dividing by 2. So then in my curly braces, I'll put my answer to 15 over here. I have negative 9 over 2. And then you guys solve the other one. I'm going to freeze my screen while you guys do that. So solve for x in the other one. All right, what's the other solution? 9 over 2 is correct. So you should have a negative 9 over 2 and a positive 9 over 2 in your curly braces for number 15. So questions on this one? All right, you try number 16, give you 90 seconds. And then we're almost done, but we still have a little bit more to do. All right, if you did number 16 correctly, you should have had negative 7/3 and positive 7/3. If you didn't get that, then listen closely. All right, first thing, make sure the equation's equal to 0, and it is already. Second thing is to factor the other side. So there's no GCF between 9 and 49, no x's in both terms. So then keep going through your factoring flow chart. Since there's two terms, see if it's a difference of squares, and it is. A difference of squares has a minus sign in the middle and perfect squares on each side of the minus sign. So square root of 9x squared is 3x. Square root of 49 is 7. To factor it, one of the parentheses will have a plus and the other a minus. I have a feeling you guys have those switched because we usually do the plus first. But either way, just like look at the workshop. All right, one should be plus, one should be minus. Solve for x in each situation. In one of the equations, you had to add 7 to each side, and in the other, you had to subtract it to get it to cancel out. But then in both equations, you needed to divide by 3. So questions on 16. All right, almost done. Now we just have to do what we've been doing, but now we're actually going to have a step 1. So if we look at our note sheet at number 17, or all of the ones in this set, none of them are equal to 0. So we actually have to do some algebra to get it there. So like in number 17, how could I make this 21 become 0? Then I add it, subtract it, multiply, divide it. I can subtract it. I can subtract 21, and now my right side of the equation will be 0. But whatever I do on one side of the equation, you have to do to the other side. Now, if there's a like term, I'll usually like line it up with that like term, but there's not, so I'm just gonna write it somewhere randomly. And then since there's no like terms, you're basically just rewriting it. So it's x squared plus 4x minus 21. Make sense so far? Then you continue with the rest of your steps. So like factor the other side. Since it's a trinomial, how do we factor it? Diamond method, what number will go at the top? Negative 21, what number at the bottom? And what two numbers multiply to 21, or negative 21, but add to 4? 7 and negative 3 is the winning combination. If it's going to add to a positive 4, the negative needs to be on the smaller number. All right, so then write down your factors. It's x plus 7 and x minus 3 so far, equal to 0. What do we do next? Set each factor equal to 0 and solve for x. When they're short like this, I'm sure a lot of you do this in your head, but either way, get the x by itself. So in the first situation, you need to subtract 7 to get rid of it. So what's one of my x's? Negative 7. In the other one, how do you get the x by itself? Add 3 to both sides. And then 0 plus 3 is, so then x equals negative 7 and a positive 3. Good on that one? All right, so let's, before I give you one to try, let's do one more where it's a little different. Maybe there's multiple things to move, like in number 20. All right, so really I could move stuff to either side, it doesn't really matter. Pick the side that has less stuff on it, because then it gives you less stuff that you need to move. So like I need to move this, let me close this. So then I need to move this 4x and this 1. Just take it one at a time. How do I move the 4x? How can I make that 4x become 0? Subtracting 4x would make it 0. Dividing it would make it 1. So you don't want it to be 1, you want it to be 0. So subtract 4x. And whatever you do on one side, do it to the other side. And since it's an x term, I'm going to line it up under the other x term to make my life easier. And then in the same step, I'm going to move this 1. How do I get rid of a plus 1? By subtracting it. And then I'm going to do that on the other side under its like term. So then on the right side, the 4x's cancel, the 1's cancel. On the right side, it's equal to 0. On the left side, combine your like terms. Like the x squared doesn't have any. What's negative 10x minus 4x? Negative 14x is correct. And then what's 49 minus 1? 48. Still equal to 0. Oops, didn't need to do that. Whatever. All right. So then continue with the rest of your steps. Only thing new that we're doing is now we had to move stuff to the other side. So the rest is the same. How do I factor trinomials? With the diamond method, what number will go on top? What number on the bottom? And 48 has a lot of options. What are two numbers that multiply to 48, but add to negative 14? Negative 8 and negative 6 are the winning combination. Since it multiplies to a positive, they both have to be positive or negative. Since it adds to a negative, well, there you go. They both have to be negative. So I have x minus 8 times x minus 6 equal to 0. Next thing we do, set each factor equal to 0 and solve for x. I'm kind of running out of room, but here's what it looks like. How do you get the x by itself in the first one? You're going to have to add 8 on both sides, which makes my first x value a positive 8. And the other one, how do I get rid of a minus 6? Good, and so my other x value is a positive 6. Questions? All right, you guys will try number 19. And then after that, I'll give you the rest of the time to work on your practice. All right, but try that one first. I'll project it in 2 minutes. So if you're still working on 19, I guess just don't look at the screen yet until you're ready. But also, I zoomed out this far so that you can see the other ones as well. All right, so number 19. You needed to move that 7x. How can I make that 7x 0? Do I add, subtract, multiply, divide? Subtracting it would make it 0. So then I do that on the right side, because that's what the instructions say to do, is to set it equal to 0. I do it on the left side, because whatever you do on one side of the equal sign, do to the other side as well. All right, so the right side is now 0. The left side, I just need to combine like terms. So there's no like term for the x squared. For the x terms, there is. So it's negative 5x minus 7x. Negative 12x is correct. All right, so that's how they got this in their first step. They just moved it. All right, then from there, it's what we've been doing for the rest of the notes. So since it's a trinomial, we factor it using the diamond method. So -64 on top, -12 on the bottom. The only two numbers that work for it were -16 and +4. So you would just had to play around with them until you find the right ones. All right, then set each factor equal to 0 and solve for x. So like in the first one, we had to add 16 to both sides. That's why a +16 is part of the answer. And the other one, I had to subtract 4 to get rid of the 4 on both sides. So that's why it's a -4 in the curly braces. Does that make sense? All right, and then if you want to look at the other ones like 21 and 22 real quick, they also had to move stuff. Here, let me go back to where it was. All right, they also had to move stuff to the other side to get it equal to 0, but the factoring method was different in each one. So like in the 21, I had to factor by GCF only. And number 22, what method did they use to factor? The difference of squares. So the factoring just depends. We taught you a whole unit how to do that. So just use your flow chart. Any questions? All right, so then the rest of the time will be for you to work on your practice. That gives you like 12 solid minutes. And then on Monday,